Hello and welcome everyone. So I'll be explaining this problem B of the DELTIX round spring 2021 rated for Div 1, Div 2. So the problem B, so in this problem basically you're going to be given an array, okay? What you basically have to do is turn each and every element of that array equal to -1 times that element itself, which means what I mean by is that let's say the element of that array is ai, then for each and every element you have to make it minus a of I, okay? Just that value times -1. And also one thing to notice is that here a couple of clues are hidden inside the statement. The first clue is that the number of the total number of integer or the total the input that you're going to be taking as n, the number of values that's going to be inside the array, is that it's going to be always even, okay? So even number of members or even number of values or elements. So this is a very important thing to notice in order to solve this problem. And also so the main task is that you have to just make the initial given array in a format like that, where ai should be equal to minus of a of I. And also one thing to notice is that how will you do that? So in order to do that, or to do some kind of operations and then outputting or getting the final answer, so for that or to like manipulate the elements, you would have some operations that you can perform. So there are basically two types of operations. The first type of operations is that you can, first of all, you can take any two indices. The operation is explained here is like that, like you're given two different indices, I and j, and that I would be less than of j always. So I would be less than j, okay? And I would be less than j, and you can perform two types of operations. Either you could make ai equal to ai plus aj, and aj equal to aj minus ai. So this is a very important part. Of course, you have to do that operations. But the most important part is that n will be even, okay? And also, finally, they've said that you cannot apply that operation more than 5,000 times, okay? You can choose any two indices. You can make the operations. There are two types of operations. You know what are those? ai equal to ai plus aj, or aj equal to aj minus ai, where I should be less than j. And the number of times you can allow or apply this operation is up to 5,000. More than 5,000 is not allowed. Also, no variable can be allowed or absolute value should be greater than 10 to the power 18. So it's not also possible. So in order to solve this problem, we need to keep two things to remember, is that n is even, okay, and the amount of operations that I can make at most is 5,000 for any given number of n. Now, interesting part is that here n is up to 10 to the power 3, which is quite small, right? And also one interesting or funny thing is that you don't actually need these values, or you don't have to do any kind of coding implementation with these values that you're going to be taking. So it's just useless taking the value. What we're only going to be working on is the positions, because what we have to output is that finally you have to output the number of operations. How many operations did you do, and what are those operations? Like if you had implemented type 1 operations, you would say that yes, I have implemented type 1 operations from that array by taking indices I and indices j. So that's all we care about. And in the real solution, you also don't have to worry about the values itself, because it's just useless. We're just taking the values as it's just nothing to work for those values. Okay, now we're only interested in the indices. Why is that? Why I'm saying that is because n is even, and this is going to help us for sure. Now think about it. How I approached it was that, okay, let's take, as n is even, let's take the smallest even number, which is basically 2, positive even number, which is 2, and also each and every value will be positive 2. Now what I did was, okay, I tried to make an observation, which is, let's take n only 2. If I take n only 2, so I have 2 values, so my I could be this and j could be this. Okay, now then I tried to find out, is there any way that there should be some way that I can do some type of operations in those 2 indices some number of times such that the values transform to this. Is it possible? I tried to find out. Is it possible for any of the 2 indices, it doesn't matter which one, to possibly make the desired number by allowing some number of operations only for required for those 2 indices? Now that's why I was trying to figure out what will we do if n is equal to 2. Then we only have remain I and j of, like, what, the first index and the second index, right? Now is it possible to do that? Turns out it is always possible to take any of the 2 indices, and if you perform smartly 6 operations, you can manage to deal with those 2 indices and turn them to the required number, which is basically this always, because we want that, like that. So this is actually a this is actually like a statement fully, is that it's always gonna, if you smartly do the operation, it's gonna always take 6 operations for any of the 2 indices for sure. Now why is that? Is it possible that how is it possible that always, or you could say that why I'm claiming like I would only do 6 operations and it's gonna magically do that? Yes, it's gonna do that. I'll prove it to you. But for now, let's just stick with it that only for any of the 2 indices, we just need 6 operations to make that happen, that desired values for that desired 2 indices. So by doing that, as n is even, so I need to worry about n by 2 indices. Why is that? Because for each and every indices, I'm actually doing my operation for 2 indices in whole. So what I'm trying to understand is that I'm trying to make you understand is that, let's say my array goes something like that, 1 2 3 4, let's say 5, let's say 6 values. Okay, I've already told you that I will deal with only even indices, the smallest even indices, it doesn't matter. So let's say I'm dealing with first 2 and I'm making it by doing 6 operations. Similarly, doing the second 2 indices, doing the same thing, 6 operations, and making it the desired value. Now will that fulfill my constraint? Because my constraint say that I can only apply up to 5,000 operations total. So I could claim it something like that. Okay, for 2 indices I'm making 6 operations. Think about it. For 2 indices I'm making 6 operations. For 1 indices I'm making 3 operations. Okay, so the result would something look like n by 2 times 6, which means if n is 1000, which is the highest value that they have given, I only need 1000 times 3 equal to 3000 operations, which does fulfill my request, because I can only make up to 5000 operations, which is inside my constraint. So yes, I can do that possibly. Now the big question is why it's possible to use it's always possible to use six times. Because, like, let's take you to an example and show you that it's always possible. It's a bit of intuitive and observational too, but let's just do it. Okay, so we have 1 and 100. So the first operation is what we're going to be doing. Okay, let's take I. This is my I, this is my j. Okay, let's do the first type of operations. Okay, we're doing the first type of operations. After that, what happens? We know in the first type of operations we can only add it, so definitely 101 and 100. Now what we're going to be doing, okay, let's just show you what will be the upcoming instructions. It's going to be something like that. We're going to be doing first operation, then second type, then first type, then again second type, then again first type. 1, 2, 3, 4, 5, and then again second type. These operations, these 6 operations, is going to guarantee us to find our desired values as we want. How is that? Let's just take a look at it. So we already did the first operation, and now look, the second operation is the type 2. So if I want to go for type 2, it would look like -1, of course, because 100 minus 101. Then first operations again, so 100 comes here, interesting, and -1 is there. Okay, and okay, another okay, then against the second type of operations, so 100 here, -1 minus 100 is -101. Sorry for that. -101. And after that, I'm going to do another operations, which is the number type 1 operations, which is going to basically take me to 1 here and -100, -101 basically. And oh, sorry, not -101, -1. Why is that? 100 minus 101, so definitely -1. And there go -101. And then if I do type 2 operations, what does happen? -100 minus -1 means -101, -101 minus -1, which means -101 plus 1, definitely -100. And yeah, that's how we get our final answer. Now, why is this working? Think about it. What you actually do inside those operations, what we actually do, we just add those, we just only play with those indices values, that's all. And it's pretty intuitive. I hope you get that, how it's actually working. If you act on it, just draw out some test cases and try to figure out how it's possible, and you'll see that it's always possible to do this 6 operations for every 2 indices possible. So that's how we actually did this problem. Let's take you to the code part. Code is absolutely easy. You don't have to worry about the values that you take. Yeah, that's the K that we were just trying to make you understand. N by 2 times 6. This is our K, and just basically 1, 2, 1, 2, 1, 2, and the indices for each and every consecutive 2. I actually work with consecutive 2 indices. That's all we care about. Okay, I hope it made you understand that. Yeah, till next time, goodbye.